let's write the power series expansion for the function 1 plus x over 1 minus x. In fact, we have a couple ways to do this, and let me just show you the most straightforward way. So in order for us to match this with our best friend, notice that we have 1 plus x on the top. Let's just break down the fraction. Especially, the denominator is just 1 minus x, which is exactly the same as our best friend. So that will be a good sign, right? So let's look at this as 1 over 1 minus x as the first fraction. And then for the second one, we will have plus x over 1 minus x. As you can see, the first one is exactly our best friend. But then for the second one, it's not really, because we have the x on the top. But it's not that bad, because I can just put this x on the side and then put a 1 on the top. So multiplying, so still the same. So this is the same as 1 over 1 minus x, which is exactly the same with our best friend. And for the second one, I will write down plus, put the x on the side, and then we have the 1 on the top now, over 1 minus x. And I'll put parentheses right here. And then this, it's also exactly the same as our best friend. And then I'm just going to show you the write-out version of this power series first. And then in the next video, I will show you guys how we can work with the sigma notation. For the first one, it's just that 1 plus x squared and so on. So let me write this down. 1 plus x squared plus x to the third power plus so on forever. I don't need to change anything, right? And then plus the second term, we have x times this. The x is outside, so we can just put on the x. And then the inside is just going to be the same thing. 1 plus x squared plus x to the third power and so on. Well, for the second thing right here, we can distribute the x into the parentheses. So just multiply x infinitely many times into everything inside. So we will end up with the first one stays the same, but then I will just take out the parentheses. So we will have 1 plus x squared plus x to the third power and so on. But then for the second one, we will have x times 1, which is x times x, which is x squared. So we have plus x squared, x times x to the third power, second power, we have x to the third power, x times x to the third power, we will have x to the fourth power, and so on. And now we can combine like terms, just like doing algebra, because all this is pretty much just polynomials. So here we have the 1, and that's the only number that we have, the number 1. So let me put on the 1. But as we can see, we have plus x along with this plus x. So we have 2 of them. So we can put on plus 2x. And we also have plus x squared here, plus x squared here. So we can write down plus 2 of the x squared. How about the x to the third power? We have this and that. So plus 2 of the x to the third power. And then you can imagine we have now 2x to the fourth power, and so on. Any x to the whatsoever power, we have 2 of them, right, from here. Alright, so this is the expanded version for this power series. And now let's see how we can put them together into the sigma notation. Well, the 1 is just kind of like on the outside, so let me just put a 1 on the outside. And this is pretty much the answer in the back of the book, okay? I will write down 1 on the outside plus I will write a sigma notation for all these terms. Everything on I just underline this has a 2. So I can put a 2 outside of the sigma notation. And now I will just write down my summation. N start with something, end up with infinity. So first, I'm not looking at the 2 anymore because the 2 is on the outside. And second, as we can see, we have x to the first power, x to the second power, x to the third power, and so on. And depends on what you want to put for the starting value for the n. It may be different. So we can put on as x. If you want to put on to the nth power, in that case, make sure that we start off with n is equal to 1, because the first term in the red part is when n is equal to 1, we have n to the first power right here, along with this 2. If n is equal to 2, that will give us this term, and so on. This is the same as saying 1 plus. The red part can also be written as 2 sigma and start with something to infinity x to some power. If you wanted to start with n is equal to 0, you'll see how you just subtract 1 from the exponent, from the index, not the exponent. But then you have to add 1 to the exponent right here. Because in this way, if n start with 0, you have to make sure the first thing is n to the first power. When n is equal to 0, 0 plus 1, we do have the x to the first power. These two are equivalent, depends on which one you like, perhaps. So that's the form. All right, and now let's talk about the interval of convergence and also the radius of convergence. As we can see, we use our best friend right here. So in order for us to use our best friend, we have to include that it's true only when we have the absolute value of x. And the reason I say x is because this is exactly our best friend. So you see, I just plugging x into all this x. So I'm plugging x right here. So it's true when the absolute value of x is less than 1. And that's pretty much it. That will tell you the radius of convergence. And then this is equivalently, well, 0, and then -1, +1, and it's inside. That's pretty much it. It's not too crazy because, as you can see, this is just exactly the same as our best friend. So it's this one. So the interval convergence has to be exactly the same. You just work out some algebra, you work out some sigma notations. That's all.